All right. So let's start going through this problem. We're supposed to use synthetic division here. So what's the first thing I need to know if I'm going to use synthetic division? Yes, we need to figure out what is going to go in the little box. And so we set x minus 3 equal to 0. Thank you, sir. Grab one of those bellwether pages. All right. Take this piece right here, x minus 3, set it equal to 0. Now we need to solve this for x. Oh. So what do I need to do to get the x all by itself? Yes, ma'am. Yep, we're going to add 3 to both sides. So here my 3's are going to cancel out, and so I get x equals 3. This is what I put over in this little box over here. How do I find the other numbers that I'm going to put right here? Yes, what's inside the first set of parentheses, and we're just grabbing the numbers. We're not grabbing any of the x's, just the coefficients. So what is the x with the biggest exponent on it? 3x cubed. So I write down a 3. So x cubed, and then I need every other power of x going down. So I have x cubed, then I go down to x squared. What's the coefficient on x squared? -7. So I need -7. So x cubed, x squared, then down to x. What's the coefficient on that one? -11. And then I get to my constant, which is 15. Underneath all of this, we put an equals sign and then a little leg. Thank you. Yep. Because this last piece right here will end up being the remainder. Sometimes I even put a little dashed line right here just so I remember it's only that last piece that I'm cutting off from everybody else. All right. So I've got it all set up. What's the first thing I do now? Bring that 3 straight down. Now, once I have that 3 down there, what do I do next? Multiply it by this outside number, which also happens to be a 3. So I multiply these two together. What is 3 times 3? 9. Where do I put that 9? Underneath the -7. And I'm going to add those two together. What is -7 plus 9? +2. And then what do I do with that +2? I multiply again. 3 times 2? +6. And I put that underneath the next number and we add those together. What is -11 plus 6? -5. Do I need to do anything else? Yep, I have to multiply this one now. 3 times -5? -15. I add it with the value up above, and what happens? I get a 0. And what do we call that 0 there? That is my remainder. So we have a 0 remainder here. This 3 right here, we got that from x cubed. So this 3 down here, does that also go with an x cubed? X squared, it drops 1 degree. So this is going to be 3x squared -7 used to go with my x squared. So right underneath it now, this 2 will go with just x. Plus 2x or minus 2x? Why is it a plus? because it's a positive 2x. So I'm going to have plus 2x. All right, up here, this negative 11, that was the coefficient on my x. So when I come down here and look at this one, that's going to be the coefficient on what? Negative 5. This is going to just be my constant. So it's going to be minus 5. And then this 15 up here had been my constant. And we already talked about that leftover piece being my remainder. All right. So this right here, if you take it this far on the test, you get full points, all the points. If you decide you want to take it a step further and do like what we practiced on that piece of paper that I handed out when we did extra practice in class, only when we have a 0 remainder can you try this. So if you get a remainder of something else, we can't move on, and that's just all the points there are. But if you want to take it a step further, I will give you extra points, bonus points, extra credit on the test. Yep, absolutely. The extra credit part. So I would take that 3x squared plus 2x minus 5. If I'm going to factor this, I'm going to need a box, an area model, and I'm going to need an x. What do I put here? 3x squared. That's where I put my a value. What about here? Negative 5. That's where we put our c value. What about here and here? Yes, we're going to multiply a and c together. This is where that x comes in handy. What is a times c? Negative 15, yes. Because I multiply just the coefficients together. So I have negative 15. What goes down on the bottom? My b value, which is 2. Yep. So I need two numbers that when I multiply them, I get negative 15, but when I add them, I get 2. I heard 5, and what was the other number I heard? 3, and I'm even hearing negative 3. Well, I know one of them has to be a negative because when I multiply them, I get negative 15. When I add them together, I need a positive number. Since this is positive and it's my b value, that means the bigger number between these two has to be positive. Well, the bigger number is 5. So that means the 3 is the thing that has to be negative. Yes, because if this was a negative 2 down on the bottom, that would change it around the other way. Because I want, when I add these two numbers that I have in green up here, if I put those in my calculator and I add them together, I should get this number on the bottom. Yes, yes, yes. All right, so here's the two numbers that are going to go in those two empty boxes. What else do I have to make sure goes with them when I put them up here? X's. Because when I combine those two together, it has to give me this right here. All right, 2 boxes at a time. What do these two have in common? 3x squared and negative 3x. They have an x in common. Anything else? They have a 3 in common also. Let me see if I can scoot this over just a little bit so that that is not hiding there. All right, let me try to fix this just a little bit here. Bear with me, guys. This new annotating software is not horrible, but it's not the best. All right, so we had a 3 in common and an x in common here. Why won't you go away? Whatever. Anyway, what about these two? What do they have in common? They have a 5. Positive or negative 5? Positive, because we're touching a positive box. So here's one of my factors. 3x plus 5. Then we have to go the other direction. 3x squared and 5x, what do those two have in common? X. What about negative 3x and negative 5? They're both negative, so I know I can take a negative out. Plus, it's touching a negative box here. Negative 1, yes. So x minus 1. Yeah, because it has to be a number after that. Because these are factors, so that would be the same as just saying like x plus. And I'm going to say, well, x plus what? Same thing. You're saying x minus something. So you have to tell me what you're subtracting. So x minus 1. All right, so taking it this far would get you extra credit. If you take it one step further so that you have your actual roots, you get even more extra credit. What do I do with each of these if I want the roots? Set them equal to 0. 3x plus 5 equals 0. X minus 1 equals 0. What do I do here if I want to get the x all alone? Subtract 5 first. We always have to undo addition or subtraction first. Right, 3x equals negative 5. And then what? Yep, now I can divide both sides by 3. Remember, whenever you see a variable and a number smashed up against each other, that is multiplication. So negative 5/3. I can't simplify that anymore, so I would leave it just like this. What about over here with this one? What do I do to get this one? Add 1 to both sides to get the x all by itself. So x equals what? X equals 1. So how many roots did we find? 3. My roots are this guy right here, this guy right here. Where's the third one? This one right up here. X equals 3 is the other one. Nice work. So again, left-hand side of the screen, that would give you full points on the test on that question. You get all the points there if you stop with that black box. If you want extra credit, you can choose if you want to do what's over on the right. 1 bit of extra credit just for the factoring part, so getting it to 3x plus 5 and x minus 1. More extra credit if you set it equal to 0 and find those actual roots. All right. Okay. Go ahead and pull out your review. Yesterday in class, we did, what was it, number 2 and number 4? Or number 2 and number 5, yes, thank you. So number 1 and number 3, if you look at the module from yesterday, I went over those problems in another class. So I posted that video as well as your video. So 1, 2, 3, and 5, you can go back and watch the videos that are part of yesterday's module. So Canvas, go to modules on the left-hand navigation tab, and then you would scroll until you find yesterday's date, the 8th. Because we already went over those particular pieces, though, I would kind of like to start here on number 4. Because my hope is that either in class or in one of the videos that's posted, we will have been able to go over every single question on this. All right. And I want to get through absolutely as much as we can in class. So number 1 and number 3, go back and watch the video. It's labeled which video is which. Yes, ma'am. No, but I'll do that today with us. So we'll do number 4 and then we'll go do number 6 right afterwards. All right. All right. We are supposed to, on this particular question, decide whether the following would best be described as a polynomial, as a quadratic, as a linear, or as none of these. So before we actually go through and start trying to answer this, let's talk about what it means for it to be a polynomial. Polynomials can only have positive whole number exponents. So if they can only have positive whole number exponents, there's a couple things we've got to watch out for then. If there are variables in my denominator, those would not be positive. If they're down on the bottom, they technically have negative exponents. So no variables in the denominator of any fractions. Whole numbers. Most of the time, we don't see anything except whole numbers used as exponents. But anytime you see a root or a radical, that is a fractional exponent. So no roots or radicals over an exponent. Or sorry, over a variable, not exponent. All right. And I understand that they don't have this up here, but that equals y or equals my function notation, that's all understood to be part of this because it tells me that these are functions. So it's kind of already understood that that function notation or that equals y is already there. They just didn't write it down. So let's look at this first one. 2 as a function rule. What would this look like if I graphed it? It's going to go through the y-axis because it only has a y. And it's going to be up at 2. And it's just going to be constant straight across. What does that look like? That looks like a line. So what kind of function would that be? Linear. What about the next one down? Let's talk about quadratics for just a second. I'm glad you brought that up. In quadratic functions, it must have a squared variable. And that is the biggest exponent we're allowed to have. Biggest exponent is a 2. Do we have any variables with exponents on them in part B? No. So it can't be quadratic. Polynomial. I agree, it is a polynomial. Polynomial is a pretty broad term. Technically, a quadratic is a type of a polynomial. A linear is a type of a polynomial. We want to find the best or most descriptive term here. So I agree with you that yes, this is a polynomial. Let's figure out if that is the best one for it. We already said that it can't be a quadratic because why? Doesn't have a squared variable. Could this be linear? Does it have a slope? Does it have a y-intercept? Yes. What is my slope? 1/2 is my slope. What is my y-intercept? 4. They didn't use the variable x. That's okay. That's not what makes something linear or not linear. Maybe they were talking about time. Maybe they were talking about how much money they were going to make over a certain number of hours. And so they decided to use t for time instead of x. It's still showing me this linear relationship. What about part C? I kind of like it for quadratic, except what do I see there? Yeah, I don't see an exponent of 2. Squared means I have an exponent that's a 2 on it. Here, what do you see around that variable? There's an exponent of 4. What else do you see? A radical. Is there a variable underneath our radical? Yes. This piece right here, this is the exact same as a fractional exponent. Whenever you see a radical, it's the same as having a fraction as your exponent. Is this a polynomial? No. All right. What about D? This is a polynomial. All of these variables, when I look at them, they have positive whole number exponents on them. Even this r on the end, technically it has an exponent of 1, even though I don't see it there. So all of those are positive whole numbers. Why can't I call it a quadratic then? Yeah, the biggest exponent is a 5. The biggest exponent is only allowed to be a what to be quadratic? Has to be a 2 to be quadratic. All right, let's look at E. What do we think about E? It is not a polynomial. Why not? What piece is breaking it? Variable in the denominator. So none of these. And our last one, part F, that one is quadratic. Biggest exponent is a 2. And so this one is quadratic. All right. Let's go down and look at number 6, since we did number 5 yesterday as a class. You okay? Awesome. What are they asking me to do between these two polynomials? The directions say simplify, but that can mean a lot of different things. They want me to subtract. When I'm subtracting two polynomials, what do I have to do first? We have to distribute that negative only to the pieces that come after it, because we're subtracting this second polynomial. So I'm going to distribute my subtraction to all of these pieces here. So that's going to be minus 3x to the 4th plus 10x cubed minus 2x squared plus 6x minus 3. What do I do to the first polynomial? What do I do to the first polynomial? For right now, after I distribute, I just bring that first polynomial straight down. Nothing about it changes. It's like if I distribute a 1 to it, it all stays exactly the same. 7x to the 4th minus 3x cubed plus 11x squared plus 14x minus 3. Nothing about that guy changes. We've got two different methods for combining these together. We've got the horizontal method, or we've got the vertical method where we stack our like terms. Which way do you guys want to do it? You want to do it horizontally? All right, I heard vertical. We can go through and look at it both ways. I will set it up both ways. All right. So I'm going to set it up vertically over here. And it's kind of already set up horizontally right here. All right, so for the vertical method, I want to make sure that my like terms are stacked up, one on top of the other. If I'm doing this horizontally, I want to find either some colors or some shapes so that I can mark my like terms. So 7x to the 4th, negative 3x to the 4th. Those are like terms, same ones that I have stacked right here. What do I get when I combine those two together? 4x to the 4th, yes. So 4x to the 4th, if I do it vertically, I still get 4x to the 4th if I do it horizontally. And then I move on to my next term. So there's a minus 3x cubed. Are there any other 3x cubes? Or sorry, any other x cubes? Yes, I have a 10x cubed. Over here, I've got those lined up vertically. Negative 3x cubed, positive 10x cubed. What do I get when I combine those together? 7x cubed. Will that be a positive or a negative 7x cubed? Positive, because the 10 is bigger. I have a negative 3, but a positive 10. So positive 7x cubed. All right, and then I move on to my next term. I have 11x squared. Are there any other x squareds? Negative 2x squared. I have those two aligned vertically right here. 11x squared minus 2x squared. How many x squareds do I have? 9x squared. Positive or negative 9x squared? Positive 9x squared. All right. 14x. Do I have a like term for 14x? Positive 6x. I've got them vertically aligned right here. What happens when I take 14 and 6 and put it together? I get 20x. Would that be positive or negative? Positive, so plus 20x. And then last but not least, negative 3 and another negative 3 over here. What happens when I take negative 3 and I put it with another negative 3? I get negative 6. Yep, negative 6 or minus 6. It's negative 6 because I have a negative 3, and then when I subtract 3 more, I move 3 more to the left. We're not multiplying these. That's when a negative and a negative would give me a positive. When I'm just adding and subtracting, Subtracting means I move further to the left. Adding means I move further to the right. All right. Do you guys have any questions at all about this one before we move on? Let's go look at number 7. We've got a table there, and we're supposed to try to determine a bunch of different things just based on that table. How can I look at the table and determine where the zeros are? Normally, I would look for what down the f of x column? I would look for a 0. Are there any zeros down the f of x column? Oh. I don't see any zeros here. So I'm going to have to try to figure out between what numbers do we have a 0? What am I looking for? Yes, when it switches from a negative to a positive or from a positive to a negative. The reason I'm looking for that is think about when you connect the dots, right? If I start off with a negative value, so I'm down here, and then I need to connect it to something positive, what do I have to cross? I have to cross the x-axis. I have to cross over where it would be 0. So where do you see on here that it switches signs? In between -1 and 2. So I need the x's that falls in between. That falls in between what? Yep, so between -1 and 0. Is there anywhere else that you see it switching signs? -4 and 23. Yes. All right, so in between -1 and 0, because remember, I want the x's, so these two. In between these two, so in between 1 and 2. And then I heard you guys call out the one up at the very top, -25 and 2. Absolutely. So these two go together. So in between -2 and -1. You write the x parts, because somewhere in between those two x's is where we got our 0. So I want to know in between my x's, because think about how we write a 0 or an x-intercept. It's number, comma, 0. Well, the 0 part happens somewhere in between these x's. I don't know the exact number, but it's somewhere between those. We're going to write down the x's for the next 2 parts of this question also. So they ask me about a relative maximum. What's a maximum? Maximum is the highest point. Relative maximum is the highest compared to the other values that it's around. So the way I'm going to find a relative maximum when I'm looking at this table, if it's going to be a maximum, first it goes up. And then what would you have to do once you're at the top? You would have to go down on the other side. So I'm looking for where does it go up and then come down. Let's look at this. My table starts at -25, which is pretty low or pretty high? Pretty low. And then it goes where? Then it goes to +2. So did we go up or down? I went up from -25 up to 2. And then what happened? Then I turned and went down again. So this right here is a relative maximum. But I want to know, what is the x that goes with that? -1. So it's near x equals -1. I don't know that 2 is actually the highest, but I know if I look on that x-axis somewhere near -1, I'm going to see a high point, a bump. Yep, basically the opposite for a minimum. Absolute minimum, or the minimum of my graph, is the lowest. A relative minimum means the lowest compared to the other values that it's around. So I'd see it going down, going down, going down, and then it would have to turn and start getting bigger. Somewhere down here would be the low point, right? So let's pick up where we left off. We were at 2. What happens as I go from 2 to -1? Did I go up or down? Down. From -1 to -4? Down again. From -4 to 23? Up. So this one right here, compared to the point before it and the point after it, this is the lowest, right? What is the x value that goes with that? 1. So near x equals 1. Let me pull a graph up of this real fast so that we can check our work. We said that there were how many x-intercepts? 3. In between -1 and 0, in between 1 and 2, in between -2 and -1. And we think there's one relative maximum, one relative minimum. X to the 5th minus 4x minus 1. All right, so let's type this in. X to the 5th minus 4x minus 1. All right, so look at my graph. How many x-intercepts do I have? 3. Come on. I don't like this touch screen anymore. Anyway, it's in between -2 and 1, in between -1 and 0, in between 1 and 2. Do you see any high points on here? There's one right here. It's near what x value? Trace that down to the x-axis. Near -1, I see a high point. Do you see a low point, a minimum? Yep. Right here. If I trace that back to the x-axis, the x part of that ordered pair would be really close to what? Really close to 1. We want where on the x-axis is it behaving these ways. So get your answers from the x column, but we look in the f of x column or in the y column to see those changes that we're looking for. All right. We'll pick up with number 8 tomorrow. Hopefully we'll get through them all. If not, hopefully I'll have a video up of all the rest of the ones that we don't get a chance to go through as a class. So yesterday, the problems that I went over between all of my classes, I went over 1, 2, 3, and 5 with all of my classes. If you get into the module from yesterday, they're labeled as far as which questions I went over on which video. All right.